Okay, so we're looking at 7.1.4, which means the 7th grade textbook, Chapter 1, Lesson 4. So on the top of your page, I want you to put 7.1.4, then write proportional and non-proportional relationships, and then I'd like for you to put page 33 on there, because that's where we're going to begin. If you need to pause the video, you can do so now, so that you can write that. Oop, I can't believe that's on there, sorry. Alright, so real world link, it says Ms. Cochran is planning a year-end pizza party for her students. Ace Pizza offers free delivery and charges $8 per medium pizza. Go ahead and do 1, 2, and 3, and when you come back, we'll go over the answers. Go ahead and pause the video now. Alright, so if we're paying $8 per pizza, then to buy 2 pizzas it would be $16. To buy 3 pizzas it would be $24. It would be $32 for 4 pizzas, and 5 pizzas would be $40. For each number of pizzas, fill in the boxes to write the relationships of the cost to the number of pizzas as a ratio in simplest form. So the 16/2 represents that we're actually paying $8 per pizza. The 24/3, when we simplify it, ends up being 8/1 again, and that again represents $8 per pizza. The $32 was with 4 pizzas, and when you simplify that again, it's $8 per pizza, and then $40 for 5 is $8 per pizza. So what do you notice about the simplified ratios? It turns out that every single one is $8 per pizza. Alright, so this is going to be a vocab section, so go ahead and write vocab, and we're going to write proportional, and the definition for proportional is right here. Proportional means they have a constant ratio or unit rate. And then for non-proportional, you're going to write this ratio is not constant. Okay, so not constant. So write those down. If you need to take more time, pause the video. In the pizza example on the previous page, the cost of an order is proportional to the number of pizzas ordered, because every single time it's $8 per pizza, $8 per pizza, $8 per pizza. So that's proportional. Every single time we're increasing by 1 pizza and increasing by $8. Proportional. And you notice as well that these are also equivalent ratios because they can all be simplified back to the same value. And we've gone over equivalent ratios, so I don't need you to write that vocabulary. Alright, so on example number 1, what I'd like for you to do is write for me just this table. Okay? Andrew earns $18 per hour for mowing lawns. Is the amount of money he earns proportional to the number of hours he spends mowing? So find the amount of money he earns for working a different number of hours and make a table to show these amounts. So for 1 hour he earns $18. He earns $36 for 2 hours, $54 for 3 hours, and $72 for 4 hours. Sorry, I think $54 for 3 hours, $72 for 4 hours. Now, what you notice is that every single one of those would be simplified right back to 18/1, $18 per hour. So if you can write, you've copied this table by now, and then what I'd also like for you to do is copy this section, because it's amount earned over number of hours, which is 18/1, or 18. So the 36/2 can simplify to 18, or 18/1. 54/3 can simplify to 18/1. And 72/4, again, can be 18/1. So all the ratios between the two quantities can be simplified to $18. So the amount of money he earns is proportional to the number of hours he spends mowing. It's not like the first hour he makes $18 and then the next 3 hours he gets to make $20. That wouldn't be proportional, because it wouldn't be increasing at a steady rate of 18 per 1, 18 per 1. So that wouldn't be. But this is proportional, because every hour he earns another $18. So this example, it says, at Lakeview Middle School, there are 2 homeroom teachers assigned for every 48 students. Is the number of students at this school proportional to the number of teachers? Explain your reasoning. So if they're telling me that for every 2 homeroom teachers, there are 48 students, we can set this up as a ratio of 2 homeroom teachers for every 48 students. So I know that this is proportional because if I doubled the amount of teachers, I would double the amount of students. If I made it just one teacher, it would be 24 students. Okay, so the ratio would still be the same. It would be equivalent. If it were 3, all right, it would be, 72 students. So for every 3 teachers, there's 72 students. So the reasoning is it is a steady rate of 2 teachers per 48 students. Example number 2, again, I'm going to have you go ahead and copy down this table. So example number 2 says the cost is $10 for 1 ticket ordered, $17 for 2 tickets ordered, $24 for 3 tickets ordered, and $31 for 4 tickets ordered. And the story says the Uptown Tickets charges $7 per baseball game ticket plus $3 for processing fee per order. So per order is the important thing to read here. So it says, is the cost of an order proportional to the number of tickets ordered? Explain. So the table is telling me that I've got 10 over 1, I've got 17 over 2, and I've got 24 over 3, and I'll just stop there. Proportionally, this is simplified to 10 over 1. This cannot be simplified to 10 over 1. If I actually divide that, it would be 8.5 to 1. And this one would be 8 to 1. And so what I notice is that the rate is not a constant rate, and so it is not proportional. So I want to say order is not proportional, not a constant rate. It's because of that plus $3 per order that it's not going to be proportional. If it was $3 per ticket, then every time I bought a ticket, it would increase my total balance by $3. But if I buy 2 tickets, I only have to pay that one $3 fee and $7 for 2 tickets. So that's why it's going to get thrown off each time. So basically, the more tickets you can buy at once, you're saving yourself some money than ordering separate orders. All right. Example number 3. So for this one, make sure you write example 3. Let's see what you need to write down. It says you can use the recipe shown to make fruit punch. Is the amount of sugar used proportional to the amount of mix used? All right, so let's write down our little fruit punch recipe here. It's going to be 1/2 cup sugar, 1 envelope of mix, and 2 quarts of water. So it says, it's asking us, is the amount of sugar used proportional to the amount of mix used? For every 1/2 cup of sugar, you're doing 1 envelope of mix. So if I were to double this, I would use 2 envelopes of mix and 1 cup of sugar. If I were doing 3, I would increase that by the 1/2 cup of sugar and 1 more envelope. If I were going for 4, I would increase that by 1/2 cup of sugar and 1 envelope of mix. So if you notice, we've got a constant rate that we are increasing every time we come here. We're increasing by 1/2 a cup of sugar, while we're increasing by 1 cup of mix, or 1 envelope of mix. So this is a proportional, because listen, if I threw an extra cup of sugar in 1 envelope, I'm going to have it way too sugary. So it's gonna mess up the recipe. So recipes, you have to stay proportional or you're going to mess up the recipe. All right, so you're going to do this one. It says at the beginning of the year, Isabel had $120 in the bank, and each week she deposits another $20 in her account balance. So proportional to the number of weeks, is her account balance proportional to the number of weeks of deposits? Use the table below and explain your reasoning. This is a great one. Think about it, not how much is she depositing, but what is the balance each week. So at the beginning of the year, she did $120 in the bank, and each week she's putting in $20. So I want you to pause the video, try and figure that out for yourself and explain your reasoning. And when we come back, I'll walk through it with you. Okay guys, so I'm going to add a little thing that they didn't put here. I'm going to add a little 0 because at 0 weeks she had started at $120. And after 1 week, at the end of 1 week, she increased it by $20. So at week 1 she had $140. At week 2 she increased another $20, so she had $160. In week 3 we add another $20 and we get $180. Now, I don't want you guys to think that a constant rate is the same as a constant rate of change. The constant ratio and the equivalent fractions are what we're looking for. So if you were to take your 1 over 140 and your 2 over 160, they should be equivalent if this is a proportional thing. Now, in 1 week you had $140. In 2 weeks you had $160. If you simplify this, it's going to be 1 over 80. And so you're saying right now that in 1 week you saved $140, and in 2 weeks you did $80 a week. And then for the 3 over 180, now you're saying that each week you're saving $60. That's not the case. You started with a bigger amount at 0 so that your ratio is no longer going to be the same. So that's what I want you to see, is that it's not like, oh, this is +1 + 1, this is +20 + 20, because I know I kind of did that little idea right there. No, what it is that because my starting point wasn't there, my ratio is going to be off now. Okay? You have to start at 0, 0 to be able to have the same ratio going. You can't be at 0, 120. All right, example number 4. The tables shown represent the number of pages that Martin and Gabriel read over time. Which situation represents a proportional relationship between the time spent reading and the number of pages read? And then explain. So for number 4, it gives us pages that Martin read. He read 2 pages in 5 minutes, 4 pages in 10 minutes, and 6 pages in 15 minutes. And Gabriel read 3 pages in 5 minutes, 4 pages in 10 minutes, and 7 pages in 15 minutes. And so what we need to look at is if we change each of these and we simplify them, do they come out to the same amount? Well, 2/5 is 2/5. That's as good as it's going to get. 4/10 would be simplified to 2/5. And then 6/15 would be simplified to 2/5. Whereas over here for Gabriel, if you notice, Gabriel's went from 3/5 to 4/10, which would tell me that he reads 2 pages every 5 minutes, but right here it said he read 3 pages for every 5 minutes. And then with this one, I mean, that's even more messed up because I can't even simplify that to 2/5 or 3/5, which is what I would need it to be. So he's not reading at a constant speed, so he's not reading at a proportional, he doesn't have a proportional relationship. So what I notice is that all the ratios for Martin's quantities are 2/5, so his is proportional. Gabriel's is not. Gabriel's not reading at the same steady ratio each time. He's not reading 3 pages every 5 minutes, or he would have read 6 pages in 10 minutes, and he would have read 9 pages in 15 minutes. He's not reading at that same steady rate. Maybe it got more complicated. Maybe some pages had pictures. Who knows? Okay, so Gabriel is not proportional, but Martin is proportional. Okay. All right, guys, that ends our lesson for 7.1.4, proportional and non-proportional relationships. Remember, really basic equivalent fractions. Can you simplify all of the ratios to the same ratio? All right, guys, thank you so much. Have a wonderful night. See you in school.